Good morning, everybody. Welcome back to lecture number 38. So last time we talked about wave shaping circuits, and today we will solve the exercise and hopefully we'll jump ahead to chapter 7, digital systems, okay? Reminder, we will have the quiz on this Thursday after tomorrow. It will cover up until half-wave rectifiers. If you see half-wave rectifiers, anything before that is required, including Zener. Zener is covered before half-wave rectifier. Okay? So let's do a quick recapture. Chapter 9, the material after measure 2. We defined what is LED. We said the diode, the regular diode, operates either in the forward bias, on, or reverse bias, off. Diode is a one-way directional device. The current will flow in one way, not the other. Except Zener. Zener, the current can flow in both directions. We talked about Shockley equation, which will not come in the quiz, but it may come in the final. We talked about the ideal diode model. We replace it when it's on, we replace it with a short circuit. The other model, what was the other model? Replace it with a battery of 0.6 or 0.7. When the diode is off, no current flows. Check these conditions when you solve the circuit. Remember these steps: assume, analyze, check. We do this if we have a diode with ideal diode and what? And a constant voltage. When we have AC, these steps are not useful. Why? Because when we have AC, the diode will turn on and off, on and off. So the first step when you see the diode problems, you see, is it DC or AC? If it's DC, I follow these steps. If it's AC, I need to think further. Assume status. And I told you a smart way to guess. Look where the higher voltage, if the diode's anode is closer to the higher voltage, assume it's on. The diode is reversed, closer to the cathode closer to the higher voltage, assume it's off. Then analyze. Once you analyze, you come up with VD and ID. If you have two diodes, VD1, VD2, ID1, ID2. And then check. What do you check, ya Mishal? Mishal Sadiq al-Salman, what do you check?
The condition.
Condition of what? Sadiq al-Salman.
The current.
Of what?
If it's close or...
Of the diode itself. VD and ID. Okay? These are the conditions, okay? Memorize them. If the results are not good, you change your assumption. We talked about this circuit. Remember this circuit? 2 is higher voltage, so you replace it with a short circuit. Here it's -3 is closer to the anode. You replace it with what, ya Hatim? Open circuit. Awesome. When you do the circuit analysis here, do you use Ohm's law directly or not? When you replace this with a short circuit, how do you calculate the current? Ohm's law, 2/1, okay? Remember when you have a bigger circuit, like this circuit, you have two diodes. The diode 1 is at a higher voltage, connected to a higher voltage than diode 2. So that's why we assume diode 1 is on, diode 2 is what? Off. Then we talked about what, ya Shabab? We solved some problems and we talked about the ideal piecewise linear model, and we said, if you see in the problem, assume non-ideal diode model, he should tell you whether to use 0.7 or 0.6. Usually it's one of those two numbers, okay? The only difference is you replace the diode with, in the ideal with short circuit, in the non-ideal you replace it with what? A battery. And then if it's a battery, you calculate the current is 5 minus 0.7 over 2.5. They node voltage, okay? Then we solved this circuit. And we said this circuit is better to be solved using what method? Mesh. Why? Because it has a super node. Okay? It has a super Then we talked about a zener. We said the zener operates at either forward, but if we're operating it at forward, we are wasting money. It is still can work as forward. Or the reverse. Our favorite one is the reverse. And we said the reverse is what? When it operates at the reverse, it is equivalent of a battery that has a plus minus, plus at where? At the cathode. لأن احنا في reverse region. This could be maybe 5 volts, which is maybe VZ, or 3, or 2, or 200, depending on your application. Then we talked about الشواحن, half-wave rectifier. We talked about smoothing capacitor. We talked about full-wave rectifier. And we talked about our most practical circuit in EE234. This one you should tell it to your family, to your friends. It's a good circuit to know, okay? Interviews, they will ask you, okay, you did some electrical engineering. What is the phone charger? You can dissect it. شرح لهم. تقول إنه في transformer, في له full wave rectifier, في له smoothing capacitor, في له what? Regulator. وإيش هو regulator?
خلي الفولتج constant.
Constant. And one way to have it is to put Zener diodes. And what did we say? What sort of Zener diodes we put? Our favorite Zener diodes, والاثنين اللي مواجهين بعض هذه. These two. This is the best circuit. If you put two Zeners facing each other, at the positive cycles of the AC, this one will act as forward, one as reverse. The negative cycle, one is reverse, the other is what? Forward. And we solved some examples. So let's solve another example here. And these examples are a bit more important. Why? Because these are the ones that we see in the old exams. So if you see more than 2 diodes in the exam, most likely it is solved by what? It's solved by the method of finding sample inputs, and then you plot the input output. So look at this circuit, for example. Is it DC or AC? AC. معناتها لأنه طويل. It's AC. How many branches we have? We have 1, 2. The first one has a diode and what? And a Zener diode. And what did I tell you if we connect a Zener diode with other diode? We want it to operate as a battery of 9.4 volts. So this is 9.4, this is assumed to be 0.6. So 9.4 plus 0.6, what will happen? It's 10. So I need 10 volts positive to operate what? To operate this in the forward bias and to operate this in the reverse breakdown. So anything above 10 volts, we will clip our voltage to 10. So what's our upper cap? 10 volts. In other words, if I have 10 volts, this is V input, this is V output. I'm taking V output either to this branch or this branch. By design, both of them cannot be on at the same time. Why? Because we are not allowed in EE to put a battery of 5 volt and a battery of, 7 volt negative. Are we allowed to do this? No. هذه نفس اللي يوصل اشتراك بالسيارة يوصل اشتراك ويقلب البطارية وتطلع شراب نفس الشيء. You cannot enforce 2 voltages to be at the same time. Can you enforce 2 pressures to be at the same time? You cannot. So same for electrical engineering. So by design, question in the final exam, can those 2 branches be active at the same time? No.
So on the condition it's AC.
Well, AC is nothing but multiple DCs at different times. So at a single point of time for AC, one will have 6.7, one will have minus 8.3. The only difference is that they change in time. But for a snapshot of time, it is one single voltage.
So what will happen? It will draw a lot of current.
What will happen is beyond the scope. It depends on how much resistance you have in the wires. the conditions, which switch was closed faster than the other. يعني it's dynamic. Even EE students do not try to, because this is, in engineering, do we care about physics or we care about practicality? So this is not practical design. Okay? Okay, Jihad? You want to leave now? You can. What is the, okay, do we have Zener diodes? Okay, I didn't finish that. So at 10 volts, we're capping it at what? 10 volts. And then other than that, we will have a one-to-one relationship up until I reach minus 1.8 volts. Why? Because it's 0.6, 0.6, 0.6. I have, these are regular diodes, flipped in direction. So if you have a positive voltage, this will be reverse bias, open circuit, reverse bias, open circuit, reverse bias, open circuit. So you need to have a negative 0.6, a negative 0.6, a negative 0.6, which is minus 1.8. Negative means here it's 1.8 higher than here to turn on this in the forward, this in the forward, this in the forward. Once you turn all of them in forward bias, you will have a battery of 3 batteries of how much? 0.6, 0.6, 0.6. So this circuit, this is how we plot it. Okay? Any input higher than 10, it's capped at 10. Then it's a linear relationship. None of the branches is active up until I reach 3 diodes, which is minus 1.8. Okay? Okay? Any question about how to plot? You will have in the final exam these plots. Input, output. Then if I supply it with a sinusoidal signal of amplitude of 15, you see from 0 to 10, from 10 to 0 up until minus 8, the input will follow the output. Why? Because this is what? Open, this is open. واضح؟ واضح يا جهاد؟ واضح؟ When one of those branches is on, we impose a battery model, either minus 1.8 in this branch or 10 volts positive in this branch. Remember, this is a Zener diode, will give you 10 volts. Here it says 5. And then here is another diode, forward bias, will give you what? 0.6. If this, which is what we see it here, at this period of time, at minus 1.8, these 3 are forward bias. Even though they are flipped, بس إن عشان في negative voltage هنا, if you apply minus 5 volts, this means it is plus 5 at the negative term. So D5 has a higher voltage drop than D4 than D3. So the sum of all of them is what?
1.8.
Yeah. If you're struggling to understand this, think of this example. If you apply 5 volts to this battery, will this diode be on or off? On. Okay, if I put plus, minus, and I make it minus 5, is it the same?
Same.
That's what I meant. Get it? واضح? Any question about the polarity? Okay. The other example, it's ugly. Why it's ugly? Because we have a resistor in series with what? The 2 diodes. So how to solve this circuit? The solution is provided here. For this circuit, both diodes are off. If I have minus 5 and 5 volts, this should be V input. Fix it in your slide, okay? If V input is between minus 5 and plus 5, input will follow the output. So at minus 5 and 5, input will follow the output. So up until I reach 5, the input will follow the output. Why? Because I need 4.4 and 0.6 to be this forward, this reverse. Or -5 or more for this to be forward, this to be what? Reverse, breakdown. Let me repeat one more time. If you have voltage above 5 volt, D7 will be reverse breakdown, D6 will be forward bias. 0.6 plus 4.4 is 5 volts. So the output will be 5 volt plus the voltage drop across what? The resistor. Not only 5 volts, the output will be now.
Less than 5.
Why? Because we'll have a voltage drop across the resistor. So solving this example, which is a bit challenging, when V input exceeds 5 volts, D6 turns on forward bias, D7 reverse breakdown in the third region. So this acts as a battery of 5 volts, this acts as a battery of 0.6 volts. Then the current given, the current is what? V input minus 5 over 2000. Why over 2000? Because we have two resistors, Sheba. It is V input minus 5 volts over R1 plus R2. V input minus 5 over R1 plus everything in series. V input minus 5 over R1 plus R2. Get it? Let's go back. So that's why the input is what? 0.5 of V input plus 2.5, which is 5 volts. Actually, it will be more. It will be more than 5 volts. So if you look at the figure, this is the figure, it keeps increasing. So a correction. It's a voltage drop, but it will add with the 5. Because you have one zener this way, the other zener that way, then you have a resistor. So this will be plus minus 0.6, this will be plus minus reverse breakdown, like a battery. No, 4.4. This will be IR plus minus, the current enters here. So this will be added. Okay? It's very important to understand. I think this is the most difficult circuit in this chapter, because هذه فيها مقاومة in series. So what will happen is the output will keep increasing up until you reach 10 and where the peak. So if you apply the equation, V output equal what? 0.5 V input plus 2.5. If you apply 10 volt, this will be 5 plus 2.5. No, 15. It will be 7.5 plus 2.5. The max is 10 volts, which is here. The max is 10 volts. Follow this equation. 0.5 V input plus 2.5. For the negative voltage, it will be 0.5 V input minus 2.5. So if the input negative, minus 15 peak, minus 15 times half is what? Minus 7.5. Minus 2.5 is what? Minus 10. That is why you see here the output is at minus 10. So any question about this example? The last problem, it's a design problem. I'm not going to solve it for the sake of time, but if you have any question about it, let me know, okay? This is the last problem. It says design Clipper circuit that has transfer characteristics shown in A and B. So clearly, if you have to do this, the best way is to have the two zener at 2.4 plus 0.6. This will give you 3 and minus 3. So this is how to design the circuit. The other one, if you have for part B that gives you the linear characteristic, then you have to include 2 zeners and a diode, which is equivalent to this example. Okay? Try to do this example yourself. design problems إن شاء الله ما هي جاية في الاختبار. But it's for your own benefit. من خيارات كيف بيقول لك design. جاكم design of major 2؟ إن شاء الله ما راح يجي. If there is a problem coming in the final, I will put a new YouTube video and you'll see it. Okay? Okay? Maybe one day before the exam. How many of you did not watch the help session? Do you regret not watching the help session? Yes or no?
No.
Okay, الحمد لله.
أخطاء كانت تافهة.
Not في help session?
ما شفت.
Did you check it? So maybe your mistakes were in the help session.
لا يعني المفروض أقسم.
إذا ما تبي تذاكر في الاختبار I get it. إذا ما تبي تذاكر في الامتحان على الأقل شوف الهلب سيشن. Okay? Okay. Any question about chapter 9? Are we now experts in the diet? For those who are attending, do you want to do a quick quiz now? نلغي quiz حق خميس؟ الحين سهل خميس بتصير صعب. لا ما أنتم جاهزين.
في زنر ولا؟
Everything is possible. يكون في اثنين زنر. بالعكس الزنر is my favorite. لأن الزنر خلاص تعرف إنه you want it to be what؟ مشعل. You want the zinner to be what? Battery. Okay? Okay, let me take a few minutes break and then we will start the new chapter. Chapter 9, chapter 7. Okay? Do you know, guys, why I repeat the diet examples? You like this repetition of the examples? My goal is to connect everything from the beginning of the chapter up until the end. I want you to have a roadmap to know what's going on. Okay? Let us open the new chapter. So again, as always, the best way is to get the slides updated, ya shabab. Every time when we finish the chapter, I make some edits. You can check, yesterday I made an edit. Okay? Let's start chapter 7. And it is my favorite, okay? الحين حنا no more electrical engineers, we are more into computer engineering. So before I begin, what's the difference between electrical engineering and computer engineering? هنا في الKTP.
Electrical engineering deals with analog signals and computer with digital signals.
Maybe that's a good way of saying it, but well, before 1950s, there was no computer science. Everything was electrical engineering. Then when they started to have programming languages, computer science became a separate school. But the hardware elements of the computer stayed with electrical. Because back then it required capacitors, resistors to have a computer. After the 60s, 70s, transistors became more and more available. Then electrical engineering said, stop. We cannot just deal with the computer aspect. يعني هو الchips والsemiconductor at a programming level. Electrical engineering said, what we're going to do is we're going to do the hardware part and stuff. The computer science, they said, we're not going to touch the hardware, we're going to do the coding part. But there is an area where they do the links between hardware and coding, which is what we see computer engineering. VLSI, very large scale integrated circuits. They care about how fast the signals are moving from when you execute the code and in the hardware. Her computer engineering is hybrid, electrical computer science. Probably that's the easiest way to think about it. So today's course, actually it's our EE students, they do not study this material in EE. They study it in computer of engineering. What, COE? You studied it.
202?
Yeah.
Yes.
انت you studied 202 انت aerospace؟
لا انا اخذها كم؟
انت ايش الميكانيكال؟ COE 202 اخذتها؟
لا انا اخذ
انت اخذتها.
أنا أخذتها قد أخذتها.
خلاص ما يحتاج. So we're gonna exclude النخلي from the average in problem solved here because it's not fair. خلاص طلع برا الافريج. يعني انت familiar with the multiplexer وهذا. Piece of cake for you. خلاص correct me if I make mistake. خلاص.
إن شاء الله نذكرها في حاضر ممكن.
It's easy. Before we begin, what are the objectives of chapter 7? This week we will cover only 7.1, basic logic circuit concepts. Section 7.2, representation of numerical data in binary form, اللي هي 1001. Combinational logic circuit, synthesis of logic circuits. These are a bit advanced, but now let's focus on the basics, okay? We need to have some basics. So when you measure the pressure using the sensors in the lab, have you ever used computer to measure the pressure or the temperature? Well, it was all needles. I'm asking you, the mechanical.
We didn't measure.
temperature or vibrated.
How did you measure the pressure? ساهم at that gauge
هو إلكتريك يطلع لي الرقم.
or electric يطلع لك رقم. But you haven't seen signals like that before.
No.
In your ME courses. Okay. Maybe if you have softwares that do process analysis, they plot signals like that. If the pressure is high, the signal is high. If it drops to negative, over time. Maybe the negative pressure means, I don't know what's negative pressure, but speed of the car. If you plot the speed of the car, it's analog. Analog يعني at every instant of time there is infinite number of values. تذكرون في الابتدائي يقول لك الخط المستقيم يتكون من عدد لا نهائي، عدد لا نهائي من النقاط. من باب أولى الكيرفز اللي شيء شكله زي كذا يتكون من عدد لا نهائي من القيم. Why? Because it can be 0.01, 0.011, 0.0112 عدد لا نهائي من القيم over a period of time. So you cannot store all the possibilities. The only thing you can store is maybe the range. The range, it could be from 10 to minus 15, something like that. But between 10 and minus 15 there is infinite number of values. That is the analog signal. ايش معنى analog بالعربي؟ قياسي. Can you Google it? ايش معنى analog يا شباب؟ تناظري. تناظري يعني direct mapping. Each amplitude has in a continuous range has unique significance. Each value of time has a unique significance. For example, position sensor produces an analog signal that is proportional to a displacement. Each amplitude represents a different position. At every single picosecond there is a specific value. لحظي. A digital signal, no, it's either 1 or minus 1 or no, this is, it can be either high or low. high or low. This is if you have a binary, two-level language. If you have, for example, a signal that has maybe either 1 or 0 or -1. analog ولا digital. هنا عندنا two values, either 1 or 0. 1 corresponds to plus A volts, 0 corresponds to minus A volts. But if I have 3, either 1 or 0 or -1, is it analog or digital?
Digital.
It's in the family of digital, but this is not binary. Binary ايش معناه؟ ثنائي القيم. هذا logic digital circuit with two binary values, okay? Either 1 when the voltage is plus A volts, maybe plus 5 volts, or 0 when the voltage is what? Minus 5 volts. This can be also 0 volts. But for this specific example, it has specific values, either 1 or 0, 1 or 1. This one, either 1 or 0 or -1. The point here, you have limited options of output. Here, you have infinite options of output. Here, you have very limited, only 2 options of the output, either high or low, 1 or 0, plus A or minus A. Until you can do your math. It can be 100 volt and 20 volt. Yes.
Doctor, can't it measure the numbers between them? It can't, right? In the digital systems.
In the digital system, لما تحط الفولت ميتر بتشوفه 5 فولت هذا معناه 1. لما تحطه تقيسه minus 5 فولت هذا معناه 0. لما تحطه وتقيسه 0 انت في السيستم حقتك يا تحطه 0 و 5 يا تحطه minus 5 و 5 اذا تبي باينري لازم فقط 2 فولت appear. ممكن تحطه 1100 يطلع لك 100 تقول هذا 0 يطلع لك 1000 تقول هذا 1. It depends on your system, بس الكي بوينت اللي انا ابغاك تفهم الحين ان for an analog signal it has infinite values, for a digital signal it has limited number. In this case, how many numbers we have? Two voltages, either plus A, minus A. If it's plus A, we can translate it to 1. If it's minus A, we translate it to what? 0. Okay? Here, we can translate it to what? Either 1, 0, minus 1. هذه مو binary. هذه اللغة فيها 3 حروف. هذه اللغة كم حرف فيها؟ حرفين. هذه اللغة كم حرف فيها؟ infinite. ممكن أطلع لي بلغة 5. ممكن أقول لك والله في عندي نص وماينس نص. Only one of those 5 values. This is still digital, but is it useful? It appears that the most useful, يا تركي, the most useful one is the binary one. اللي هي 1 و 0. يا في جهد يا ما في جهد. يا في جهد positive or جهد negative. Is it clear? For digital signal, only few restricted ranges of amplitude are allowed. Better is to have two levels. I can have 3, I can have 5, but it's by design. And each amplitude in a given range has the same significance. يعني أي شيء يعني الواحد والزيرو they have the same significance. Most common are binary signals. هذه binary يعني إيش؟ ثنائي. That take an amplitude in only 2 ranges, and the information associated with it is either logic 1 or logic 0. Here, if I have plus A volt, logic 1. If I have minus A volt, logic 0. Another engineer would say, no. I want to have a plus A to be logic 1. 0 volts means I have to shift this here, shift this blue curve here. If I have 0 volts, I have 0 logic. That's good. It's both acceptable. Okay? Another student say, I want to have 5 levels or 3 levels. We often encounter analog signals usually في المعامل, in the plants, instrumentation of physical systems. The physical systems always gets measured by analog signal لأنها ظواهر طبيعية. Speed of the car is measured by analog. Displacement of the distance, عداد السيارات, is analog. If you want to present it in the computer screen, you have to convert it to digital. That's another field. We'll talk about it later. But for now, I want you to understand that, for example, pressure transducer. إيش هو transducer? What is the transducer?
يحول physical values to electrical.
It's a device that converts the physical quantity into an electrical signal. It has sensors in it. It has antenna. It has cables. It has everything baked in في الترانسديوسر. من الحساسات إلى الأسلاك إلى الباور سبلاي, هذا كله يسمى إيش؟ فمعناته أن السنسرز are part of transducer. Transducer يرسل لك السيجنال إلى النكست ستيب. يعني أنت لو عندك pressure of, what's the unit of pressure? You put it into transducer, you will get electric signals, okay, in volts. This is variable. The higher the Pascal, the higher the voltage. Lower the Pascal, lower the voltage. If there is no pressure at all, 0 Pascal, what will be the output? 0 or -5, depending on the design of circuit. فيها زينر, ما فيها زينر, فيها diode, forward bias, سالفة طويلة. Okay? So a pressure transducer can yield a voltage that is proportional to a pressure versus time in the cylinder of internal combustion engine, محرك الاحتراق الداخلي. اللي هو تسمونه انتم عداد الار بي ام كذلك، نفس الشيء، نفس الفكره، فيها pressure measurement، فيها اشياء كثير. The point I want you to understand is the word transducer, not only sensor, it's a system that has a single component of it. داخل الترانسديوسر في بلوك صغير هو السنسر. اوكي، السنسر اذا انضرب حيغير المقاومه، حيفتح لي زنر، حيطفي لي دايود، وهكذا. فالترانسديوسر ايش هو يا خالدي؟ is the device that is responsible to convert an analog physical value into corresponding electrical signal. Analog ولا digital? It depends. It can be digital. Okay. الفالف status, for example, عندك valve في البايب لاين، عندك valve. I don't know. This is the valve يا شباب، هذا الرمز حقه. عكس. I don't care. الفالف عندك either on or off، صح؟ في الترانسديوسر most likely you will have a circuit. If there is a voltage, it give you 1 or 0. Or plus 5 volts and maybe minus 5 volts. You don't need an analog. So transducer also works as digital. You know the status of the valve, on or off.
نفس تانك البنزين، مثل عبارة البنزين اللي تقيس البنزين، مرات تقيس كم باقي الكيلو عشان ما يحضر بنزين، هذا تعتبر transducer.
Well, the way it works is it measures the level وفيها ماب على الرينج حق السيارة. فالترانسديوسر is actually في التانكي حق البنزين، التانكي عندك العوامة. إذا العوامة نزلت E، إذا العوامة ارتفعت F، صح؟ إذا العوامة نازلة you will have, I don't know, you will have resistance that is low فتعطيك current أعلى. I don't know about the circuit, but I can come up with a circuit. Maybe you have Zener, okay? You have battery. Then you have a variable resistor. إذا العوامة نزلت الريزستور يكون أعلى أو العكس. It depends on the design. Bottom line is by changing the level of the العوامة, the value of the resistance change, the current will either increase or decrease. So the electric signal will change. So that maybe the voltage will be higher if the benzene is full. How it calculates the range? This is computer coding. I'm not an electric cars engineer بس you get the idea انه في some component عندك from the physical system that converts it into what? Electric signal. Okay? Then the computers are used to process this information. Can get the range, can get safety, alarm, etc. The microphone is another example. If you speak, the vibrational signal will push the sensor and it will vibrate. It will change the resistance. It will change the voltage. Okay? Temperature sensor. The higher the temperature, remember one of the equations in physics, R equal rho A over L and rho في الفيزياء تذكرونها؟ Physical resistance. Rho changes over time. Temperature may increase or decrease over time. The temperature تغير ال resistance value without physically changing the resistance. Okay? Converts temperature to a voltage. Here we have, for sure, we have a variable resistor inside here, thermostat. Value of resistance change. If the value of the resistance change, the current jihad will change. Okay? Okay, Nasrallah? What? So voice and video editing conducted in the digital domain. YouTube, camera, it's everything in digital. Nobody is doing analog voice recording. Everything is digitized. يعني instead of having this signal, everything is digitized. Steps. Like it. Digitized. رقمي. Okay? Well, we'll talk about the advantages next lecture. Time is up. Any question about this lecture? And by the way, this is the last part. We will not cover a microcontroller further. There will be no microcontroller in the final exam because you took it in the lab, what are doing, okay? Any question?